Welcome to the lecture. Today we are going to see nodal analysis with independent sources. So when we go for nodal analysis, when we want to determine the voltages in a particular circuit, we can go for the nodal analysis. So here in this nodal analysis, we can apply the Kirchhoff's current law to write the node equations. It is applicable for all planar and non-planar networks. First, we will see what are all the procedure to solve the nodal analysis. So, for nodal analysis, first we have to identify number of nodes present in the given circuit. Second one, you have to assign one node as a reference node. Then, we have to assume all the currents are leaving at each node. The third step, apply KCL at each node and write the nodal equation in terms of current. And last, we have to solve the simultaneous equations to find the node voltages. First, how we can define node? It is nothing but connection of three or more branches at a point. We can say it as a node. So, when we go for a junction, we can say when two or more branches are connected. So, when the node is present, defaultly the junction come into the picture. Now, we can use this procedure to solve a problem using nodal analysis. Example, calculate the current through 2 ohm resistor for the given network. As per the procedure, first we have to identify the number of nodes. So, in this node, in the given circuit, we will have a T node, that is one we can consider as a reference node. Then we have to name the node for remaining two nodes. Let VA be the node voltages at node 1 and VB be the node voltage at the node B. Now, solution, we have to write the KVL equation at each node. Sorry, KCL equation at each node. Apply KCL at node A. Now, so what is your first step? We have to identify the number of nodes. Then we have to name the nodes. Then second step is you have to assume all the currents are leaving at each node. So as per the assumptions, all the currents are leaving at each node. Now we are applying the KCL at node A. We have to check whether any current source are present at each node. Now at node A, there is no current sources are present, so that we can write there is no incoming or outgoing current. So here we are having no current sources, so we are writing as a 0. 0 equal to VA minus 20 divided by 1. So why we are writing VA minus 20 means the given voltage source is opposite to the assumed current direction. So that we are writing VA minus 20 divided by 1 plus VA divided by 1 plus VA minus VB divided by 0.5. Now combine the equations for VA and VB. So here we can take VA outside, then we can write 1 plus 1 plus 1 by 0.5 minus 20 minus VB divided by 0.5. So we can simplify this equation, that is here it become 4VA minus 2VB minus 20. So we can write in terms of simultaneous equations. So the equation becomes 4VA minus 2VB equal to 20. So take this as equation number 1. Similarly, apply KCL at node B. So there we have assumed the node voltages VB. So in node 2 also there is no current sources, so that we can write 0 equal to VB minus 20 divided by 1 plus VB by 2 plus VB minus VA divided by 0.5. Now again we can write the coefficients in terms of VA and VB, so that we can write minus VA by 0.5 plus, we can take VB outside. So if you take VB outside, it become 1 plus 1 by 2 plus 1 divided by 0.5 minus 20. So if you simplify the equations and write minus 2VA plus 3.5 VB minus 20. So we can write in terms of simultaneous equations minus 2VA plus 3.5 VB equal to 20. Take this as equation number 2. Now we can solve this equation 1 and 2. Either we can use Cramer's rule or we can simplify with the help of the calculator. Now solve the equation 1 and 2. If you solve the equation 1 and 2, then we will get the values for voltages VB and VA and VB. So by solving the equations, we will get the node voltage VA 11 volt and VB 12 volt. But still the problem not completed. They are asking find the current through 2 ohm resistor for the given network. So where the 2 ohm resistor is present, which is connected at the node B. So by using that node voltage at B node, we have to determine the current through 2 ohm resistor. Now, so determine the current through 2 ohm resistor. So the formula for current through 2 ohm resistor, can write I 2 ohm equal to, the 2 ohm is connected at node 2, so that we can write I 2 ohm equal to VB by 2. We know that the node voltage at B is 12 volt, so that I 2 ohm equal to 12 divided by 2. So the current through 2 ohm resistor is 6 amps. Thank you.